Hello everyone. So today let's solve the problem sum of nestings, right? So this was asked on the 2017-2018 ACM-ICPC NEERC Southern Subregional Constant Qualification stage, right? So let's see what the question states. You can just go through the problem. Yeah, I'll just summarize the question so that it will be easier for us to solve the problem. Yeah, so just give me a second here. 1 second. Yeah. So what the question states here, we are, sorry, 1 second. So yeah, we are given n brackets, meaning so we have been given number of pairs of brackets. Is n is nothing but the number of pairs of brackets, and k and k. So k is nothing but here this one total nesting sum. So this is nothing but the total nesting sum. I'll just write here t sum total sum, and n is nothing but the number of pairs of brackets, right? So pairs of, so I'll just write here brackets. I'll just mention this like this. Yeah, so we have been given n nothing but the number of pairs of brackets and k nothing but the total nesting sum. What we need to do, we have to construct the regular bracket sequence of length, regular bracket length, this one sequence of the length, this one 2 minus n actually, length 2 minus n, such that the sum of the nestings of all the brackets is equivalent to the k, is equivalent to the k, right? So this is equivalent to the k, right? So if it is impossible, then we have to print impossible. If it is impossible, then we have to print impossible. Just remember this. This is also one of the cases, right? So otherwise, print any valid sequence they have given. So there may be multiple valid sequences. We can print any of them. That's what they have mentioned in the question. So let me read the question loud. Just listen to this carefully. So we have been given n nothing but the number of pairs of brackets and k nothing but the total nesting sum. We have to construct a regular bracket sequence of length 2 minus n, 2 minus n, such that the sum of the nestings of all the opening brackets equals k, right? If it is impossible, then we have to print impossible. Otherwise, we have to print any valid sequence. Yeah, so this is the question. Let me delete this one entirely. Now, let me come to the question. Let's do one thing. So here they have been given 3-1 actually. We can do one thing. We can turn this one, or we can just visualize this one in the form of graph actually. We can just visualize this one in the form of graph, or we can just go with a simple, very simple greedy approach as well. Yeah, we don't have to go with graph at all. So as we are solving the problem on this one graphs actually, let's visualize this one as the graph and then apply the greedy meaning. So greedy here acts as the valid path actually. Yeah, greedy will be using the greedy approach to find the valid path, right? So that is the reason we'll be going with the greedy. Mainly, let's consider, or let's visualize this one as the graph. Let's do one thing. I'll just directly consider this one. What do we call? Let's discuss the approach first, followed by the complexities, and then let's write the code. So this one has to be that they have given 3-1. So the output that we need to get here is this, and the we have been given input 4-6. The output that we need to get here is this one 2-5. So it is impossible here in this case. So see here, if there is no solution, we have to print impossible. We have there is no solution, I believe, for the third one. So they have given here impossible. Yeah, we have idea on the question as well as the input output part. Let's do one thing. Let's quickly discuss the approach part. So here I have considered the same first example that they have given in the question, right? So the output has to be this one basically. Just give me a second here. 1 second. Yeah. This one. The output has to be actually this one. Yep. Uh, so I'll tell you one thing, or I insist you to try out the same whatever we discussed in the approach on the second by considering the second or the third example rather than the first one, so that you understand the question better, right? Or the approach part better basically. To implement that one in the form of code, it will be easier for you. So I just insist you to try out the same thing, whatever the approach that we discussed by considering the example 2 or 3. Yeah, so this is fine, man. Yep. Now, before moving on with the step-by-step explanation, let me tell you one thing. We will be going with a greedy on graph, nothing but we'll be going with a graph visualization. Then we'll be applying the greedy on the graph. Greedy acts as the valid path here. So greedy is used to find the valid path basically. Yeah, on the graph. So let's move on with the step-by-step explanation. So this is the graph diagram. So this is nothing but just text based actually. I have just showed the text based. You can just look into it actually. First path is 001. So we have been given 3-1. The output that we need to get here is basically this one actually. Now what do we call? This one is the output that we need to get here, is right? Sorry, 1 second. Yeah, this is fine. So first we will go with the 0, 0, 1. So this is nothing but the opening bracket, this one. Next we will be going with the vertex 1, 1, 1. So this one is nothing but the closing bracket here. So this is nothing but 0, 0, 1. We can consider 0, 0 with a value 1 actually, or the weight 1, right? 1, 1 with a value 1, or the this one value. Let's not consider weight. Let's consider the value. So next is nothing but the vertex 2, 2, 0, right? So this one we are considering 2, 2, 0. So here it is nothing but the closing bracket. So here again 3, 1, 0. This is nothing but the opening bracket here, opening bracket here, right? So sorry, this has to be opening bracket itself, man. 1 second. Opening is done. So here again we have went with the opening bracket. So yeah, again we have went with the opening bracket. So this time it is the closing braces actually. This is fine. Mm, Now we are just going with the opening braces here, 3, 1, 0. So this one 0, 1, 2, 3. So this one, right? So this one 3, 1, 0. Opening braces. Next we are going with a 4, 2, 0. So this one actually. This is closing bracket actually. This is fine. Next we are going with a this one closing bracket. And finally, this one we have went with a closing bracket, which is 6, 0, 0. Meaning here, this one you can count the opening and the closing bracket set overall. Actually, it has to be 3, 3. Actually, it has to be balanced, right? So that's what the graph says actually, right? So here at the end has to be like this. So you count the this one opening and the closing brackets. Your opening brackets are 1, 2, 3, and the closing brackets are so it has to be at the end. It has to be 6, 0, 0. Right, so this one is valid actually. This one is valid. In simple terms, if we represent that one in the form of braces, so this one. So we can consider this one. This is fine. So explanation, I have went with a simple explanation here. So each node is equivalent to the state. State in the sense position, open, and remaining k. So each node we are going with the state, position, open, as well as the remaining k. And each edge we are going with the decision either opening bracket or the closed bracket, right? So valid sequence is nothing but the path from 0, 0, k. In our case, k we have been given so this one, what do we call k? We have been given 1, right? K we have been given 1, right? So here, just give me a second. Yeah, a path from 0, 0, 1 to 2 into n 0, 0. So 2 into n in the sense it will be 3 actually. So we have been given k1 and n this one 3. So this will be 2 into n comma 0, 0. So what we got here? Finally we got this one n into 2 is nothing but this one, what we call 6, and finally 0, 0. So this is what we got here as well. So we got 6, 0, 0, which is a valid path, which is a valid path basically. This is how we will be making use of this one. This is what the explanation says, and also this is why we will be making use of the greedy as well. So greedy because to find the valid path basically, right? So we have got here 0, 0, k is nothing but it is equivalent to 2 into n 0, 0. We have got 6, 0, 0 previously, right? So the output is 6, 0, 0, which is equivalent to this one, which is equivalent to the this one bracket, right? So which is absolutely correct in our case, which is absolutely correct. So the output that we got here is this one, which is equivalent to the output that they have mentioned for the example 1 within the question. So our approach works absolutely correct here. So as we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part. So what will be the time complexity here? The time complexity would lead to big of n. So why it is big of n? Because loop runs exactly 2 into n times. Yeah. So overall time complexity would lead to big of n. And what will be the space complexity here? The space complexity would lead to big of n. And the string builder stores the sequence of length 2 into n. So overall space complexity we can consider big of n. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n and big of n respectively, right? So now as we are completely familiar with the approach and the complexities part, we are good to write the code. Let's start writing the code. So yeah, now let's start writing the code. We'll be making use of the different utilities, right? So I'll just go with import java dot util dot start. So this is fine. Next, let's go with a class here. I'll just go with the main. You can just go with any name that's relevant to the question. So let's make use of the scanner here. SC equals new scanner. Scanner is enough for this particular problem. We don't have to go with this one actually, buffer reader, print writer, or the custom input and custom input output, right? So I'll just go with here. Scanner. This is fine. So before the scanner, actually, let me go with the main one. So I completely forgot this one. Yeah. Let me remove this one. This is fine. Yeah, let me remove this one as well. Yeah, let me include. We don't have to include input output. This is fine. Let's directly make use of the scanner. So I'll just go with scanner. C equals new scanner. So this is fine. Let me go with system dot in. Let me go with system dot in, and let's go with long n equals c dot next int. So this one will be sc dot next long actually. Sc dot next long. Dot next long actually. This is fine. And also k equals here scanner dot next long as well. So this is fine. We are just reading n and k here in simple terms, right? So this is fine. Next, the maximum possible nesting sum is equivalent to n into n minus 1 by 2, right? So let's write this one in the by making use of if condition. If n into n minus 1 by 2, if it is less than k, if it is less than k, we know that maximum possible nesting sum is n into n minus 1 by 2. If the maximum possible nesting sum, if it is less than k, then it's impossible, right? So in that case, we have to print impossible as they have mentioned in the question. That's also one of the criteria. So I'll just give here impossible within the string. So this is fine. Let me make this one capital I, or else we might get the error. Yep. So next we have to terminate, or we have to get, we have to exit from here. So let me exit from here. So this is fine. So the next thing here would be, let's go with the current number of the this one opening braces, right? Nothing but the, what do we call that? Opening parentheses that are open actually. So this one will be string builder. Mm, so before this one, as I've said, we have to go with the opening braces, right? So let me go with int if your open equals 0 string builder, because we have to build the resulting our result string efficiently. I'll just go with sp variable sp new string builder. This is fine, man. Next, let's move on with a for loop. So I'll just go with for int I equals 0, I less than, we have to go with the 2 into n, so I plus plus. So within this for loop, so we can place the opening parenthesis if we have remaining and k, if the k allows it actually, right? Then how can I write this one? Let me write simple if condition here. Open, so this has to be open, sorry, sorry, this has to be equal 0, not the, so I'm writing within this if condition, right? So if this one open less than k, sorry, got confused here. Open less than k and k greater than or equal to open, then if we can place opening brackets, and if we have remaining, and if the k allows, then we have to place the opening bracket, right? So this one will be sb dot append, right? So this is fine, append. Yep. Now let's do one thing. Let's subtract the current nesting from k. So this one k equals k minus open. K equals k minus open. And then let's increment the open. Else what we need to do here. So we have to place the closing bracket, meaning I'll just go with a string builder, sorry. Let me make use of the append here. So this one will be closing parenthesis. So this is fine, I believe. We have placed the closing bracket here, and we have to decrease the open, this one, what do we call? Opening parenthesis count or opening bracket count, right? So I'll just go with open minus minus. Yep. Finally, we are left with only one thing here, nothing but we have to print the final sequence. I'll just go with the system out println here. System out println, we have to pass string builder variable sp, right? So this is it for the code. So before checking the code with the different inputs or the examples, let me copy paste the signature starter template. So I'll just come here. let me paste this one over here, right? So this is fine. Uh, yeah, let me come to the question. Let me copy this one, paste it over here. Int open equals 0. Yeah, semicolon. Where is this? 30. Mm, scanner dot next long. Oh, this one has to be capital L man. Where is it? This is fine. 24. Yeah, now we are getting the correct. This is also one of the valid sequences, man. This is also one of the valid sequences, right? So this is fine. So let me copy this one. Mm, let me paste it over here. Yep, we are getting the correct output, right? So you can clearly see here. So this one, let me copy this one. We have to get impossible for this. So this one we have to get impossible. It is not possible at all. Yeah, we are getting the impossible. So let me copy this one. And first one, you don't have to worry. So either we can get it in this way, or we can just get the opening, closing, opening, closing, opening, closing. That also we have to get in the form 600, right? So if you remember 2 into n comma 0, comma 0. I had explained you that one in the approach, right? So this is fine. Let me hit the submit button here. Let me choose. So which one is this? C sum of nestings actually. This is fine. And yeah, one more thing. Let me hit the submit button. One more thing. This problem can be easily solved by only greedy method. You don't have to visualize this one in the form of graph at all. So you can just solve very easily uh, by making use of the greedy approach. You can just go with a simple greedy approach and solve it. But as we are solving the problems on graph, I just wanted to visualize this one in the form of graph and then make use of the greedy in the sense, so to find the valid path basically. Yeah. So that I wanted to do, that I wanted to show basically. That is the reason I have made use of this one here. I have showed you the graph, this one, what do you call visualization. We have got the wrong answer. What's wrong, man? Here, just give me a second here. So that is also one of the valid answers that we got here, right? So what's wrong here? So what mistake I have done here is, see, here in the line number 34, actually, it has to be open less than n, not k. We are checking whether open less than n and k greater than or equal to open, right? So I have, in a hurry, I have typed k, I believe. Right, so now, yeah, this works correct for almost this one, most all of the test cases actually, but some of the first test case would fail, right? I believe. So yeah, now we are getting the correct output actually. So that one also is one of the valid answers that we got actually in simple terms. See, this we are getting this one nested one right side actually, left side, and the non-nested one this side, right side. This one also works, and the first one also works actually, but it was taking wrong answer. Anyways, so I'll just copy this one entirely. So let me come here, paste this one over here, and submit, and hit the submit button. Yeah. Let's see whether this works for all the test cases or not. Let's wait for some time. So here you can clearly see in the toast it is showing accepted. The verdict that we got here is accepted, right? So whatever the solution that we have written works absolutely correct for all the test cases. Yep. I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.